Yeah, so this is analysis of the A puzzle from the future problem from the Codeforces round 696. So, Mike has two binary integers, A and B, of length n, and they can have leading zeros. And so, he wants to construct an integer D such that first integer C is a result of a bitwise sum of A and B without transferring carry, which means that something like 0110 plus 1101 would sum to be 1211 and not a transfer of the two. Or this plus this would sum to this. And so after that, Mike replaces equal consecutive digits in C by one digit. So going back to this example, these three zeros will be replaced by 1 0. And these two 2's will be replaced by 1 2, giving you 0 2 0. And so Mike has integer B, but he lost integer A. And so we're trying to find any binary integer A such that D will be the maximum possible value of an integer. So here is an example. So let's go with this test case. B is 0 1 1. So now let's just go through some random cases for A. So let's say A is 0 0 0. Right. If you add them up, 0 0 0 plus 0 0 1 is 0 1 1. But there's two consecutive ones here, so that'll just replace itself as 1. So obviously this doesn't seem like the maximum possible value, but let's just keep going through other possible values. Next is 1 1 1. Adding that with 1 0 0 1 0 1 1. That will get you 1 2 2. When you have two repetitive 2s, so you replace it with 1 and 2. 1 0 1. Adding that 1 1 0 1 1 will get you 1 1 2, which you replace with 1 and 2 as well. So essentially now you're trying to find the maximum value of this final output here. So how would you do that? So first you can see that to get any max number, you want the highest possible first value. So if the number is 0 1 1, to get the highest possible value of D in this scenario, you want the first digit of D to be 1, because 1 is only greater than to 0 in this scenario. It's 0 plus 1 is just 1. So the new number, so this is B, right? The number for A has to start with 1, because you want to try to maximize this first column right here. So once you've done that, right? So B is equal to this, A is equal to that, D is equal to. So let's say now A is equal to 1 here. So the sum of B and A is 1. So since D is 1, and then this next value for B is also 1, for this scenario, if we make A to be 0, then this value of D will also be 1, causing these two to cancel out. And to get the maximum possible value, you don't want any of the digits to cancel out. So in other words, you don't want this second condition to be true. So yeah, you test to make sure that the second value is not equal to the first value. So if this first value of D is 1, then you want the second value to be either 0 or 2. And so to get 0, that would mean that if this value of B is 0, then you have to add 0 here, meaning this value of A would be 0. And again, to get 2, that would mean this value of b would have to equal 1, and you have to make this value of a equal to 1, so that they're summed up. So that's what you do for if this value is 1. What would you do if the value is 2, for example? So if it's 2, then you want this value to be 1. So 1 or 0, but 1 would yield you a larger number than 0. So you want to just aim for the 1. And so to get 1, there's 2 paths to this. If the next value of b is equal to 0, you can do 0 plus 1. But if the next value of b is equal to 1, you can see that if you plus 1, that you get 2, and that will cancel out this 2 right here. So the path you want to take is adding 0 such that this value will equal 1. Meaning since 2, 1 doesn't cancel out, but 2, 2 cancels out. And so essentially, yeah, you just go through each value and then checking these conditions to make sure that no 2 numbers get cancelled out. And so here is a Java solution to this problem. So essentially, yeah, it's the same thing as what I explained before. You go through, read the problem statement, get the value of the first character, and then you loop through all the characters in the integer or in the string, and you'd make sure that there's no repeating numbers, and you're maximizing all the possible numbers. So yeah, that's essentially a Java solution to this problem.